conjugate. Is that so? We're talking about the conjugate complex number. So in complex conjugate, may you please loop your mic so that I can hear your noise? Complex conjugate and division of a complex. So when we're talking about what we call the complex conjugate, we say that on complex conjugate, we said if Z is nothing but equals to A plus IB, is a given complex number, the given complex number where A and B are real numbers. And I is nothing but equals to square root of -1. Then it's been a while when I'm trying to admit Karao. I don't know whether she's facing a network problem. I was saying, then the complex, the complex number Z star, which is equals to A minus IB, is called the complex conjugate. It's called the complex conjugate. Z is equals to A plus IB. Are we still together? Hello?
Yes.
So you guys, you are given the slide, right?
The what?
The slide with your lecturer. Did he send you the slide?
Yes.
Yeah, there is a mistake there on your slide when he was doing complex conjugate on the example number 1. When they say Z is equals to A plus IB, and then they say Z star is equals to A plus IB, it was supposed to be minus. I will find you have to change that for yourself. It's your job as a student or as a learner to change. Oh, good.
Yes.
So now, if we're saying write the conjugate of the following example, we said write down the complex conjugate of the following complex number. Number one, let's say you're given z is equals to 3 plus 2i. And let's say number b, you're given that z is equals to 5i minus 6. Let's say we have got those things. So what will it be, our complex conjugate? What is going to be our complex conjugate when we have such? Here, solution. Our number one, our z star is nothing but going to be equals to what?
2i.
Sorry? Our z star is nothing but going to be equals to 3 minus what? 2i. Why? We change the sign of the one that is on the real number. Are we still together? On the imaginary number. We change the sign of the imaginary number. This is someone who is at the place which is noisy. Karabo, may you please loop your mic. So now it means this one's this star, but this one's supposed to be number 2. We can't have 1 and b. Our z star here is nothing but going to be equals to minus 5i minus 6. Are we good?
Yes.
So now, we can't waste our time while we will be busy talking about the complex conjugate, unless if you didn't understand the complex conjugate, I can give you some more questions, then you try to write complex conjugate with it. Now you please try those two, then we proceed. Let's say 3. Now you please try those two. Minus I plus 4. Number 4. Say we'll go to Z is equal to, let's say 2 minus 4i. There we go. What did you get?
Number 3, I get 1i plus 4.
I plus 4. Number 4, you get
2 plus 4i.
2 plus 4. So can you see that this thing is very, 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 very simple?
Yes.
So can we proceed?
Yes.
Okay. Now let's talk about what we call the modulus. The modulus of a complex number. So the modulus of a complex the modulus of a complex number Z is the distance of Z from the origin. Is the distance of Z from the origin. So now we write the modulus of Z as Z. This is the modulus. Are we good?
Yes.
Or simply as R. R is also our what? Our modulus. Are we still together? So
Yes.
now, as far as we're concerned, let's say, can we go to the next slide?
Yes.
So let's say we said consider there's a person who logged in and the mic is on and someone is laughing and the noise is very disturbing. So let's say consider the number Z, which is nothing but equals to X plus YI. We're good. So if we draw, we're going to have this kind of a thing. And we know ourselves that this is Y. And let's say here we've got YI. And if we draw a line here, let's say line from here to there. This our point Z is nothing but equals to X plus YI. Then if this one is from here to there, this one is from here to there. Let's say here is perpendicular, nothing but 90. This is our x-axis, which is given by the real of Z. And that other one, this is the line of y-axis, which is given by what? The imaginary of Z. Are we fine?
Yes.
So now, this is the line of x-axis, and that's the line for y-axis. So from Pythagoras theorem, from Pythagoras theorem, we know that our r squared, remember this is r is equals to the modulus of Z. Are we good? Then from theorem of Pythagoras, we know that our r squared is nothing but equals to x squared plus y squared. Therefore, if we square both sides, if we square root both sides, we will find that indeed our r is nothing but the square root of what? Of x squared plus y squared. But what is our r on the diagram? We said our r is nothing but equals to what? Hello?
Hello.
We said our r is nothing but equals to what in the diagram?
modulus of Z.
Yes, it means where they say R, we're going to substitute with the modulus of Z. It means we're going to have the modulus of Z is nothing but equals to the square root of what? Of x squared plus y squared. So we have an equation. So we have an equation.
No.
Can we proceed?
Yes.
Yeah.
Okay. Let us proceed. So now, let's do let's talk now about the imaginary. So if Z is the entire real number, then Z star is equals to Z. Whereas if Z is the entire imaginary, then Z star is equals to negative Z. So let's say the modulus. Let's take an example of the modulus. Now, let me try to find the example. There's someone who is doing, but the mic is on, is Karavu. Karavu, look your mic. Karavu, can you hear me? So now, let us proceed. Let's say if Z is equals to 3 minus 2i, then find the real of Z. And find the real of Z. The imaginary of Z. And the modulus of Z. I will start together.
Yes.
So how can we find those things? How can we find those things? Hello? I said the real of Z is represented by what?
By number.
By the number on the x-axis, is that so?
Yes.
So which one does it stay on the x-axis here between the two?
3.
We're good, right?
Yes.
Then the imaginary of Z is nothing but equals what?
-2.
-2. You see that this thing is simple. And the modulus of Z is nothing but equals to what? X squared plus y squared, which is nothing but going to be equals to our x is 3 to the power 2 plus our y minus 2 to the power 2. Then what is our solution?
Square root of 13.
Square root of
13.
18. Is it difficult?
No.
Can I proceed?
Yes.
Okay. Let's say they say if our Z nothing but equals to minus 2 plus I and our W is equals to 3 plus 2I. Find expression of number A. It says Z plus 2W. Let's first answer A. We're going to say this is equals to what is our Z? It's minus 2 plus I. Is that so? We're substitution. Are we good?
Yes.
Then plus 2 into what is our W? Is 3 plus 2I. Are we fine?
Yes.
Then this is nothing but going to be equal to. And then we understood everything from here, where we started. Is that so?
Yes.
So now, we are going to remove brackets at that other side. This is plus I, then plus 6 plus 6I. And remember the one for real, they add each other. And the one for imaginary, they also add each other. Are we fine? Then we're going to say minus 4 plus 6. Then we get nothing but what? 4.
Oh.
Then plus 7. I. Ah, we're good.
No. You say?
Hello?
Second step.
This one. Oh,
Yes.
this is 4. We did a mistake. It means here is going to be 5. Is that so?
Yes.
Thank you very much. Then this is 4i, which make this to be 5i. We're good now, right?
Yes.
They say now let's find z minus w. We did this for subtraction. Is that so? This is minus 2 plus I minus our w is 3 plus 2i. Then we remove the bracket. This is minus 2 plus I minus 3 minus 2i. Then which is nothing but going to be equals to minus 5 minus I. Are we fine?
Yes.
Maduga, where are you? Where this is someone who look like a crazy person.
What do you mean, sir?
Like where or the noise that we are hearing from your mic. So
Oh,
now let's proceed. So did you understand on what we were doing?
yes.
Let's say they say find z to the power 2. Then this is nothing but going to be equals to what? What is our z? Our z is nothing but minus 2 plus I. Is that so? But it's raised to the power 2. Then since it's raised to the power 2, this is nothing but going to be equals to what? We are going to have minus 2 plus I multiplied by minus 2 plus I. Are we fine? Hello?
Yes.
Okay. So now, uh, can you finish up? You are done. That's all. You have got 4 minus 4I plus I squared. Is that so? Hello? Guys?
Yes, that's correct.
So, but we know ourselves that indeed, this one I squared is nothing but equals to what? Minus 1.
One.
Then that's where we are going to have 3 minus 4I. Are we fine?
No.
Okay,
Sorry.
where didn't you get it? Hello.
Step number 4.
1, 2, 3, 4. This one.
No.
This one.
Yes. Richi substitute hapo nonika I squared aripangi squared.
Now, remember I squared. Okay. Arandetwa. Means I squared is equals to -1. In other words, when they say I squared, we're going to substitute with -1.
Okay.
Did you get it?
Yes.
So can we now proceed?
Yes.
Okay. Let's go and talk about the polar. Let's go and talk about the polar, whereby you guys, you're going to be introduced to something new. Yeah, I can see that in your notes, something just been written. So let's consider the diagram that represents. Again, let's consider this diagram. Now, this is our y. Now, this is our x. And if we draw, so we're saying this is perpendicular, and here we've got a theta, and here is our 0, and here is our r, this is our y, this is our x. So this is our yi, we know that. So now, we know from the trigonometry that cos of angle theta is nothing but equals to adjacent, and now we use SOHCAHTOA. Hello?
Yes.
We know that cos is adjacent over hypotenuse. We find. But let's make x the subject to the formula. Therefore, our x is nothing but going to be equals to what? R cos theta. Are we fine?
Yes.
And our sine theta is nothing but equals to y over r. But if we make our y subject to the formula, we'll get that indeed our y is equals to what? Hello?
R sine theta.
Yes, r sine theta. Are we fine?
Yes.
Yes.
So now, as far as we are concerned, if we are having such, and we know that this one is given by z equals to x plus yi. Is that so? Can we go to the next slide?
Yes.
So since we know ourselves that indeed our z is equals to x plus yi. What is our x? Guys, what is our x?
X equals to R cos theta.
Yes, where there's a x, we substitute with r cos theta and plus. Where there's a y, we substitute with what? R sine theta. Are we still together?
Yes.
Yes.
So if we take r as a common factor, we're going to get that our z is nothing but equals to what? Remember, I'm doing what? I didn't write. Oh my God. I'm doing a polar form. Polar form. Oh, fine.
Yes.
It's a polar form. So if we take r outside, we're going to have what? Cos theta
Plus I.
plus
I.
I sine theta. So this is what we call the what? The polar form of a complex number. Are we fine?
Yes.
Yes.
So we know from our diagram that indeed the tan of angle theta is nothing but going to be equals to what? Y over x, is that so? Then theta is equals to tan arc y over x. So this angle is called the angle theta. So, but how do we get that? Since ourselves, we know that sometimes our z is given by a plus ib, then our modulus r is equals to the square root of what? E squared plus b squared, is that so?
Yes.
And our theta is nothing but equals to tan arc b over a, always. It says tan arc, the number of the imaginary of z divided by the real of z. Did you get it? Hello?
No.
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 I also don't get it.
Let's say we've got z is equals to 4 minus 3i. So how do we get the modulus? This is square root of what? 4 squared plus minus 3 squared. Then what is the solution?
Five.
Sorry?
5.
You get
5.
5, right?
Yes.
Okay, nice one. Then our theta is equals to tan arc minus 3 over 4. And what is the solution?
Negative 36,87.
You get what?
Negative 36,87.
So on this one, we have to pass through another diagram for us to understand that one. So it means when we continue, we are going to start here. Are we fine? Because we don't just write it like that. We have to add something on the angle. Are we good?
Yes.
Yes.
Yeah, it means let me just end here for today because we have to add something and I have to go to another class now. because network is not favoring us. Is there any question before I end the class, guys?
Yes,
No.
to ask you, sir,
Yes. May you please ask first?
do you by any chance have question papers that covers this topic so that maybe we can be able to practice using the
To you, Vic, practice with those examples that we are doing.
examples?
Yeah, everything on the slide, you have got a slide, you have got the examples that I'm treating, so you have to practice with those things. Don't go and fetch something that you are not told.
Okay.
Are you answered?
Yes, thank you.
You're welcome.